So 5.D.2, another one of our special products. This one is referred to as squaring a binomial. So the idea of a single binomial, two terms, that is squared, right? The exponent of 2 there on the outside. So you see a whole bunch of a's and b's in front of you on this top half of this page. These are the two formulas. We have one for plus and one for a minus in your binomial. The only difference in the formula, notice, is the plus versus the minus right there. What we're showing you again down below is just where they come from. Where each of these came from would be if you multiplied it out. Now here's the key. When you see a plus b squared, we want to realize that that squared means it's this thing times itself. A plus b times a plus b. Or same with a minus b. And then you could draw your 4 arcs and combine your like terms. The difference is in this thing compared to 5D1, your like terms don't cancel. Your like terms are actually the exact same. 1ab and 1ab would be 2ab. But this approach, right, this multiplying it out, to me, honestly, is a great way to go. You can memorize these formulas if you want, but that's a very specific set of a's and b's and positive signs and things to remember to use the formula correctly. So to me, these formulas are more about just making sure we understand to not make a very, very common mistake. This is one of the few mistakes, one of the few wrong things that I put in my notes. This big mixed trick box where it says, don't do this, okay? So I'll just go with the plus, but it would be true for the minus as well. If you have a plus b squared, and I'm going to even make sure I write a do not equal here. I don't want any confusion. This is what we don't do. Do not take this squared and apply it to each piece, right? Do not take the squared and apply it to the a and the b separately as an a squared plus b squared. That doesn't work. That doesn't make sense. Right here, the formula is showing us we can't do that, right? That would not work. There's this whole other 2ab term. This only worked in the other form, which is what I'm going to compare down here at the bottom. So it says always write it out, which is essentially what I just have above in the box there. But when you see a plus b squared or anything, any binomial squared, I just recommend writing it twice. Okay, that's what I recommend, and then drawing your arcs. But the key is that there's the difference between these two problems. Here, the 3x squared, we have 3 squared and x squared. Here, and then that would be 9x squared. Here, we cannot do that. We cannot square each piece. We would need to either use the formulas above or write it out, right? 3, and then do your 4 arcs. 3 times 3 is 9, 3 times x is 3x, another 3 times x is 3x, and an x times x is an x squared, giving me x squared plus 6x plus 9. If I bring the x squared up front, combine those like terms, and bring that 9 out back. So with this formula there above, again, you can use it. You can determine the a and the b, and you can plug them into that big form, or you can simply always write it out. And that's the real key. That's the thing that we want to make sure we don't do, is we do not want to make that very common mistake right there. That can derail problems very easily, very quickly, both in this section 5D2 and throughout algebra. So that's why I've got this big box with lots of exclamation points and stars. Normally when I'm doing this on the board in class, I just start drawing arrows to it and really making a huge deal out of this, because this is such a simple mistake to make and very, very common. And again, it's completely wrong, never works, and completely derails the problem every time. So let's take a look at the next page. Let's take a look at a couple examples. So here's the x plus 3. Now I just showed it to you with writing it out and drawing the arcs. I'm going to go ahead and show you how this would work with the formula. But like I said, it's not a formula that I even feel is that necessary to learn. So the idea would be you'd identify this as the a plus b squared. So that means we know that a is x and b is 3. And then you would need to have memorized the formula a squared plus 2ab plus b squared to plug those into. All right, that's the formula way, to take the x, plug it in there, to take the a and b of x and 3 and plug it in there, and to take the b and plug it in there. Then, simplifying this to an x squared, 2 and 3 is 6, so 6x, and 3 squared, 9. So that would be the formula way to get that answer, but like I said, you just on the last page, you get the same answer by just writing it out. And so for the next two examples, that's actually all I'm going to do. I'm not going to bother cramming the formula anymore, just pointing out that when you see this squared on a binomial, take the time to write it twice. Now, just draw your 4 arcs. 2x and 2x, 2 times 2 is 4, and x times x is x squared. 2x times negative 1, negative 2x. Then the negative 1 times 2x is negative 2x, and a negative 1 times negative 1 is a positive 1. That's my only x squared term, but I've got a couple x terms. Negative 2 and negative 2 is negative 4x, and bring down the 1. And done. So nothing different than what we learned before, just making sure you write it out in that first step. And then one more example here, same thing. I'll write x squared plus 3x times itself, right? That's what the squared is telling me to do. So now, first arc, x squared times x squared, we're gonna add those exponents and get x to the 4th. X squared times 3x, again, it's x to the 1st, so that'll be 3x to the 2 plus 1, 3. The next arc, 3x times x squared is another 3x cubed. And the last arc, 3x times 3x, 3 times 3 is 9, and x times x, again, x to the 1st, x to the 1st, gives you x to the 2nd. And then, once you got your 4 arcs for 4 terms, we combine those middle terms that are like terms, and get 6x cubed. And there's our final answer.